This section is radical equations. So first things first, if we've got that two things are equal, we can raise both of them to the same power, just like before when we could multiply the same thing to both sides, divide the same thing, add, subtract the same thing to both sides. We can raise both sides to the same exponent. It's the same thing as when we were solving equations. The key thing is if you do it to one side, you have to do it to the other. We're going to use this to get rid of our roots. So what power can we raise both sides to so that we no longer have a root on that left side? Well, we can square both sides. But remember, we got to do it to both sides. So when we square on this left, the squared and the square root cancel. 3 squared is 9. And this is one, since we are raising both sides to a power, we really need to be checking our answers on these, because we will get some that will get answers that don't actually work. And so we'll plug it back into the original. So 11 minus 2. 11 minus 2 is 9. Square root of 9 is 3. Equals 3. We're good. So that really is our answer. Now let's look at this one. We need our square root to be completely by itself. So what we want to do is subtract our 1. We still have this 4x plus 1 under our square root. On the right side, we'll have x minus 1. When we square both sides, we've got to square that whole right side as one quantity. So what this means is we have x minus 1 times x minus 1. On the left, these are going to cancel. We've got 4x plus 1. When we distribute on the right, we'll have x squared minus 2x plus 1. We've got an x squared, so we've got to have it equal to 0. And positive 1 minus 1 cancel each other out. Factor out an x. So you've got two answers. We'll need to check both of them. Our original was the square root of 4 times our x plus 1. And then plus 1 equals our x. And on the other one, it would be 4 times our 6 plus 1. So let's check this left side. 4 times 0 is 0. So we'll have 0 plus 1 in our root. 0 plus 1 is square root of 1. Square root of 1 is 1. 1 plus 1 is 2, not 0. So what this tells us is that 0 is not going to work. Let's check our 6. 4 times 6 is 24. 24 plus 1 is 25. So what this means is that our solution is x equals 6, but we need to state that we had x equals 0, but that was extraneous. So just like in chapter 6 we had equations with extraneous answers, we'll have extraneous answers in this section as well. And that's why we have to double check our answers. This one we already have square roots on both sides. So let's go ahead and square both sides. Left side, right side. Remember, we need to check. Six minus 1, so I'll have root 5. 2 times 1 is 2. So root 5 equals root 5. We are good. Now on this one, notice the root is not completely by itself yet. So we've got to go ahead and subtract this 2 so that we've got our root alone. But now, notice we've got the 4th root. So we're going to go ahead and have to raise each side to the 4th power. So on the left side, we'll be left with this 12t plus 4. On the right side, remember this means negative 2 times negative 2 times negative 2 times negative 2. These two will give us a positive 4. These will give us a positive 4. We get 16. We got to check. Twelve times 1 is 12. Twelve plus 4, 16. 4th root of 16 is 2. And we get 4 equals 0. Well, that doesn't work, which means our only option doesn't work, meaning our answer is going to be no solution. But remember, we've got to state that we had an answer, but it was extraneous. On this one, notice our root is already completely by itself. So let's go ahead and cube both sides since it was the cubed root. Left side. Now on the right side, notice what's going on here. It's going to be x plus 2 times x plus 2 times x plus 2. Multiplying these two together. And now distributing again. And then when we combine all of our like terms, I'm going to go ahead and just put it on this side. We're going to have x cubed plus 6x squared plus 12x plus 8. Let's get everything to one side. Factor out our 6x. And now we have to check both of them. So checking that 0 first. Zero cubed is 0. Checking the second one. So both of these are solutions. Now notice on this one we have 2 roots. We still need to get one of the roots by himself before we can square both sides. So let's get the one that's a little bit more complicated by itself. So let's subtract this root a. And then when we square both sides, on the left we're going to have a plus 3. On the right side, we're going to have to distribute. So we're left with that. Notice we now still have a root, so we now have to get that completely by himself. So subtract our 9, subtract our a. The a's cancel. 3 minus 9 is negative 6. We've got our root by itself. We can square both sides. Remember, when we square this right side, negative 6 times negative 6 is 36. Root A times root A is A. We still need to check. Square root of 1 is 1. It works. So that's our answer. This one, notice we already have one of our roots completely by itself. So let's go ahead and square both sides. Remember, this right side now we're going to have to distribute. Once again, we've got a root still. We need to get that by itself, so let's move everything away. Negative 1 does not equal 1, meaning that's not our solution. Which means we have no solution, but we need to say that m equals 4 is extraneous. So we got a number, it's just not correct. Last one. We've got 3 roots. It's the same process. Get a root by itself, square it, get a root by itself, square it, get a root by itself, square it. Alright, so let's go ahead and square both sides. Notice on this left side, we're going to be distributing. Notice we still have a root, so we need to go ahead and get that root by itself, but let's first simplify this left side. So we've got 3k plus k. Now we've got a root by itself, so let's go ahead and square both sides again. Remember, this just means times itself again. Four times 3k. Let's go ahead and get everything on the same side since we've got squared terms. Now we do need to check both of these. So this is checking that 3. And those are the same thing. So both of those are solutions.